Today we're looking at topic 10-8, experimental and theoretical probability. Our goal is to be able to differentiate between experimental and theoretical probability. So the difference between theoretical and experimental probability. Experimental probability is the result of an experiment. It's the result of an experiment, where theoretical probability is what is expected to happen. How can you tell which is experimental and which is theoretical probability? Well, an example of experimental probability would be if you toss a coin 10 times and you record a head 3 times and a tail 7 times. That's experimental probability. And the actual results of that experimental probability, the probability of tossing a coin and landing on heads in our experiment is 3 out of 10. The probability of tossing a coin and landing on tails in this experiment is 7. Understand, I'm talking about in this experiment because it's experimental. However, if you're looking at theoretical probability, which is what we've been studying so far, if you toss a coin, the probability of getting a head or a tail is 1/2. You have 2 options. One option is heads, and one option is 12. So the probability theoretically of heads or tails is 1/2 or 50%. So theoretical probability, we have a coin and we're going to toss the coin. It could land on heads or it could land on tails. The probability of heads is 1/2, probability of tails is 1/2. Since there's only 2 outcomes, you have a 50-50 chance to get a head or a tail. Again, that is our theoretical probability. Hypothetically speaking, theoretically speaking, that's what's going to happen. So again, with experimental probability, if we physically toss a coin 10 times, and 3 of those 10 times it lands on heads, 7 of those 10 times it lands on tails, our probability of heads is 3 out of 10, where the probability of tails is 7 out of 10. We can look at experimental probability to actually make predictions on what we would expect to happen out of maybe 100 tosses. So if the probability of getting a head is 3 out of 10, how many times would we get a head out of 100? Well, these are proportional relationships. So to get from 10 to 100, we could multiply by 10. And so that means that we can also multiply this by 10. So the probability of getting a head if we were to toss the coin 100 times would be 30. What if we were just tossing the coin, say, 20 times? Well, 20 is twice as many as we had initially, so the 3 then becomes a 6, and we would get a head 6 times out of 20, and so on. So then the probability of a tails, if we started with 7 out of 10, and we wanted to say, well, what would happen out of 50? If we toss the coin 50 times, how many tails would we get? Well, we multiply by 5 to get to 50, so 7 times 5 is 35. If we were to toss the coin 50 times, then we would land on a tails 30 times. So one of the questions a lot of people ask is, how come I never get the theoretical value in both experiments? Well, if you repeat the experiment many times, the results actually get closer to the theoretical value. This is called the law of large numbers. So the law of large numbers states the more times I repeat an experiment, the closer my probability is going to get to what the theoretical probability would be. So here you can see on a chart with using the law of large numbers, theoretical probability of getting a heads is going to be 50%. So you see here, this is that bar for the 50% mark. Now after just 5 trials, we get the heads 7 out of 10 times. And so we get 53.4%. After 10 trials, well, guess what? Those last 5 trials were a lot less. And so our probability is only 48.4%. Then I go to 20 trials, and look, it's getting closer to that 50% mark. And I go to 30 trials, and it's even closer. So the concept of the law of large numbers is the more times we try an experiment, the closer we get to the theoretical probability. Let's look at some examples. So this first graph right here, it shows the results of an experiment where a number cube was rolled 100 times. So if we added up all of these numbers here at the top of the graph, it would come out to 100. We're going to find the experimental probability of rolling a 3 in this experiment. So to figure out that probability, we come and we look at our bar graph, and here's the number 3, and we see that we got a 3 16 times. So our experimental probability is 16 out of 100, and then we can reduce that to 4/25. And since we tossed it 100 times, remember the theoretical probability was 1/6. So if we compare 1/6 to 4/25, 1/6 and 4/25, well, if we multiply by 4, that's 4/24. And 4/24 is pretty close to 4/25. So after 100 trials, you can see that that experimental is getting closer and closer to the theoretical. Let's look at example number 2. So on a telephone poll, 225 people are asked for whom they plan to vote in the race for mayor. What is the experimental of Juarez being elected? Okay, so we had a total of 225 people polled, and 75 people voted for Juarez. So the experimental probability is 75 out of 225. Or 1/3. Now suppose 5,700 people voted in this election. How many would be expected to vote for Juarez? Well, if we have 1/3 voted for Juarez in the poll of 225 people, and 5,700 people are voting, then we can find 1/3 of 5,700, and we can just cross multiply and then divide. So 5,700, sorry about the writing, let's try that again. 5,700 divided by 3. 3 goes into 27 9 times. So 1,900 voters will vote for Juarez. Now it's time for you to try. For these exercises, you'll use the graph of the survey of 150 students who were asked if they prefer cats or dogs. Number 1, find the probability that a student prefers dogs. Number 2, suppose 100 people were surveyed. How many would be expected to prefer dogs? And number 3, suppose 300 were surveyed. Then how many would be expected to prefer cats? Go ahead and work the U-Try, and don't forget to write your summary as well. Okay, so here's the key to the U-Try. The probability of students preferring dogs is 21 out of 25. If 100 students were surveyed, 84 would be expected to prefer dogs. If 300 were surveyed, 48 would be expected to prefer cats. I've gone ahead and written out the work down below, so if you need to see what the steps were, you can see that below. I started out with the 132 out of 150 preferring dogs. Simplified that down by dividing the numerator-denominator by 6. That gives me 21/25. I can use that 21/25 for problem number 2, where they want to know how many dogs out of 100. Well, if 21 out of 25, we need to get from 25 to 100, so I multiply by 4. 21 times 4 is 84. For the third one, on the 300 people surveyed, it wants to know how many like cats. So you're really tempted to use that original 21/25 right here. But if 21 out of 25 like dogs, then 4 out of 25 like cats. So 4 out of 25 likes cats, To get from 25 to 300, I multiply by 12. So 4 times 12 is 48. 48 people would like cats.